Good day everyone, welcome to Math with Teacher Justin. On today's topic, we're going to talk about postulates and theorems that can help us solve problems involving parts of a triangle. Alright. We know that a triangle is a three-sided polygon, and here are some theorems about triangles. First, the sum of the measures of the angles of a triangle is 180 degrees. Second, the measure of each angle in an equiangular triangle is 60 degrees. Third, a triangle can have at most one right or one obtuse angle. And last one, if two angles of a triangle are congruent to two angles of another triangle, then the remaining pair of angles are also congruent. Alright, now let's talk about the isosceles triangle. Now we have this isosceles triangle theorem, wherein the base angle of an isosceles triangle are congruent. So another theorem is if two angles of a triangle are congruent, then the sides opposite them are congruent. Alright. Okay, now let's proceed to right triangle. For right triangle, we have this theorem wherein the acute angle of a triangle are complementary. So in this example, since we have a right triangle, if we add the measurement of angle R and the measurement of angle W, it will be equal to 90 degrees. Angle R and angle W are complementary. Alright, let's talk about the exterior angle of a triangle. An exterior angle of a polygon is an angle that forms a linear pair with an interior angle of the polygon. So let's have an example. So for this example, we have a triangle as our polygon. Our interior angles are angle 1, angle 2, and angle 3. Now our exterior angles are angle 4, angle 6, angle 7, angle 9, angle 10, and angle 12. Those are our exterior angles. Now, angle 5, angle 8, and angle 11 are not exterior angles. Okay? So, they are just opposite angles of our interior angle. Alright. Let's talk about the remote interior angles. So, the remote interior angles of an exterior angle of a triangle are two interior angles that are not adjacent to that exterior angle. So in this case, angle 4 is our exterior angle, and the remote interior angles are angle 2 and angle 3. Now let's identify their relationship. So let's start first with the interior angle. We know that the sum of all interior angles, or the sum of the measurements of our interior angles of a triangle, is equal to 180 degrees. We also know that our interior angle and exterior angle will form a linear pair. Therefore, the measurement of angle 1 and the measurement of angle 4 are supplementary. So when we add their measurement, it is equal to 180. Now, applying substitution property and simplifying it, we can conclude that the measurement of angle 4, the exterior angle, is equal to the sum of the measurement of the remote interior angle. So, the exterior angle of a triangle theorem states that the measurement of an exterior angle is equal to the sum of the measurement of its remote interior angles. So, let's have some examples in solving parts of our triangle using the theorems, postulates that we know about triangles. Alright. Okay, so let's have an example. So for example, we're going to solve for the value of x in our figure. So in this case, our variable x is one of the interior angles of this triangle. So in order for us to solve for this value of x, we will use the theorem. The sum of the interior angles of a triangle is 180 degrees. So let's add all the interior angles. We have x plus 61 degrees plus 53 degrees is equal to 180 degrees. So let's add 61 and 53, so we will have 114 degrees. So let's transpose that to the other side. Changing the sign, we have x is equal to 180 degrees minus 114 degrees. Simplify by combining like terms. Our value of x is equal to 66 degrees. Alright. And let's have another example. So for example, we're going to solve for the value of x in this figure. In this example, our variable x is one of the interior angles. So one of the theorems that we will use is the sum of the interior angles of a triangle is 180 degrees. So we're going to add, so we have x plus 88 degrees plus 34 degrees is equal to 180 degrees. So let's combine like terms. 88 plus 34 degrees, we have 122 degrees. So let's transpose 122 degrees to the other side of the equation. We will have 180 degrees minus 122 degrees. So subtracting that, we will have the value of x that is equal to 58 degrees. Alright, let's have another example. So in this example, we're going to solve for the value of x. Now, looking at the figure, we are given an isosceles triangle because our base angles are congruent. So to solve this, we need to use the theorem. The sum of the interior angles of a triangle is 180 degrees. So we will add x plus 54 degrees is equal to 180 degrees. X plus x is 2x plus 54 degrees is equal to 180 degrees. Let's transpose 54 to the other side of the equation. We will have 180 degrees minus 54 degrees. So simplifying that, we have 2x is equal to 126 degrees. Let's divide both sides by 2. Our variable x will be equal to 63 degrees. Alright. Okay, let's have another example. Let's solve for the value of x. In this example, we are given an isosceles triangle. Now, we know that our base angles are congruent. So we will use the theorem, the sum of the interior angles of a triangle is equal to 180 degrees. So we will have x plus 73 degrees plus 73 degrees is equal to 180 degrees. So let's combine like terms. 73 plus 73, that is equal to 146 degrees. So let's transpose 146 degrees to the other side of the equation. So we have x is equal to 180 degrees minus 146 degrees. Simplifying that, we have x is equal to 34 degrees. Alright. Okay, let's have another example. Let's have an example. So for example, we're going to solve for the values of x in this figure. And looking at our figure, we are given a right triangle. So in order for us to solve for the value of x, we will use the theorem that the acute angles of a right triangle are complementary. So if we add x and 47 degrees, it should be equal to 90 degrees. So we will use the equation x plus 47 degrees is equal to 90 degrees. So let's solve. Let's transpose 47 degrees to the other side of the equation. X is equal to 90 degrees minus 47 degrees. Simplifying that, we have x is equal to 43 degrees. Alright. Okay, so let's have another example. So for example, we're going to solve for the value of x. In this case, we are given a right triangle. So we will use a theorem wherein the acute angles of a right triangle are complementary. So when we add x and 56 degrees, it is equal to 90 degrees. So let's transpose 56 to the other side of the equation. 90 minus 56, that will be equal to 34 degrees. Alright, let's have another example. So for example, we're going to solve for the value of x in this figure. So our variable x is the exterior angle of our triangle. So since 63 degrees and 50 degrees is our remote angle, we can use the exterior angle of a triangle theorem. Our exterior angle is equal to the sum of our remote interior angle. So to solve for the value of x, we need to add our remote interior angle. So 50 plus 63 degrees. Our value of x, which is the exterior angle, is equal to 113 degrees. Alright. Okay, so let's have our last example for today. So for example, we're going to solve for the value of x in this figure. Observing this figure, we have 108 degrees as our exterior angle. And we're solving for one of the remote interior angles of this exterior angle. Now to solve for this value of x, first we need to solve for the missing angle over here, the one beside 108 degrees. So we know that an exterior angle of any polygon is an angle that forms a linear pair with an interior angle of that polygon. Therefore, the angle beside 108 degrees is supplementary to each other. Yeah. So when we add angle A, let's name it angle A, and 108 degrees, it is equal to 180 degrees. So let's solve for the value of A by transposing 108 to the other side of the equation. So A is equal to 180 degrees minus 108 degrees. So our value for A will be equal to 72 degrees. Okay, so that is our first missing angle. We know that if two angles of a triangle are congruent, then its opposite side are also congruent, or vice versa. If we have two sides that are congruent, okay, their base angle will also be congruent. So this angle over here will also be equal to 72 degrees. Now to solve for the value of x, we can just add 72 and 72 and our missing value and equate it to 180 degrees. 72 plus 72, and that is equal to 144 degrees. So let's transpose 144 degrees to the other side of the equation. Simplifying that, we will have x is equal to 36 degrees. Alright. Now that you already know the postulates, theorems about triangle, and how to solve the parts of a triangle, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace!